What if the sun hit us today? The sun sits at the center of our solar system. It gives us light. It gives us warmth. It makes life on Earth possible. But the sun is not a gentle, constant fire. It is a dynamic, sometimes violent star. It churns and boils with immense energy. Sometimes it unleashes powerful storms into space. These solar storms can travel across the vast distance to our planet. When they arrive, they can pose a significant threat to our modern, technology-dependent civilization. We have watched the sun for centuries, but we are now entering a new era of vigilance. A new concept imagines a fleet of spacecraft working together to give us an unprecedented view of these solar tempests. This mission is born from a simple need. We need to predict its most dangerous outbursts. The goal is to provide earlier and more accurate warnings. This matters deeply. Our world is woven together with a delicate web of technology. Satellites orbit our planet, providing communication, navigation, scientific data. Power grids span continents, delivering the electricity that fuels our homes and industries. These systems are vulnerable. A powerful solar storm could disrupt or even damage them. By placing new eyes closer to the action, we hope to see the signs of a storm gathering before it is unleashed upon the solar system, giving us precious time to prepare for its arrival. Imagine standing on a coastline, watching the horizon for signs of a coming hurricane. One person with a single spyglass might see a distant cloud, but a team of observers spread out along the shore can see the storm's size, shape, and speed more clearly. When we talk about space tornadoes, we are using a metaphor to describe a complex and powerful event. These are not tornadoes in the way we know them on Earth, wind, rain. Instead, they are colossal twisting structures of plasma magnetic fields. Plasma is a state of matter where gas is so hot that its atoms have been stripped of their electrons. The sun is made almost entirely of this superheated plasma. These solar tornadoes, more formally known as coronal mass ejection solar filaments, vast ropes of this material. They are held together and twisted by the sun's incredibly powerful and complex magnetic fields, which can store enormous amounts of energy. The sun's magnetic field is not simple or uniform. It is a tangled, dynamic mess. As the sun rotates, different parts spin at different speeds, which twists and stretches the magnetic field lines. Think of it like twisting a rubber band. Eventually, that rubber band can snap. The proposed mission is not a single, monolithic spacecraft. It is a constellation, a team of smaller, coordinated satellites. This fleet-based approach is a game-changer for solar observation. Currently, we have some incredible observatories watching the Sun, Solar, and Heliospheric Observatory. Solar Dynamics Observatory. They provide stunning images and a constant stream of data, but they mostly give a single point of view. One camera can only show a two-dimensional image of a three-dimensional event. That makes it hard to understand the shape, structure, trajectory of a solar storm as it leaves the sun. This is where the fleet comes in. Multiple spacecraft placed around the sun let us see a storm from several angles at once. This technique is called stereoscopy, the same principle our two eyes use to perceive depth. With multiple viewpoints, scientists reconstruct a full 3D model of the erupting plasma cloud. Section 4. The Shield of Early Warning. So, why does this all matter to us here on Earth? The answer lies in the power of prediction. An early warning is like a tsunami warning for our technological society. It doesn't stop the wave, but it gives us time to get to higher ground. A powerful geomagnetic storm from a direct hit by a space tornado can have serious consequences. One of the biggest concerns, our electrical power grids. The storm can induce powerful electrical currents in long transmission lines. Those currents can overload transformers. That can cause widespread, long-lasting blackouts. An early warning gives utility companies time to take protective measures. Our presence in space is highly vulnerable. The world relies on thousands of satellites for GPS navigation, for weather forecasting, for global communications, and for financial transactions. High-energy solar particles can damage satellite electronics. That shortens satellite lifespans or causes outright failures. Astronauts in orbit, like on the ISS, face increased radiation risk. With reliable forecasts, operators can put spacecraft into safe mode. They can turn off non-essential systems to protect them. Mission controllers can move astronauts to the most shielded parts of their spacecraft. Section 5. A brighter, safer future under the sun. The sun will continue to be a source of wonder, a source of risk. Its cycles of activity are a fundamental part of our solar system's environment. We cannot stop solar storms just as we cannot stop earthquakes, hurricanes. But we are not powerless. Observe, understand, innovate. A new mission concept, a fleet of small spacecraft watching the sun in unison. A perfect example of that strength in action. A deeper, more complete understanding of our star. Move from watching space tornadoes to forecasting their behavior. From reaction to prediction. A crucial step for a spacefaring species. We depend on technology. We must shield it. We can spot the signs. We can buy time to act. We can build a less vulnerable technological future.